Welcome everyone, another video from Limitless Potential Technologies, the series in which we are releasing new clean energy production technologies from our garage, open sourced, and I'd like to show you what we're working on, the type of systems that we're working on today. We're also going to be talking about the electronics that we've got built for our current project. So we're going to get into a little bit of the history of the device that we're stepping up, which is this guy over here. This device here is called a Bedini motor, built by John Bedini in the 70s, 80s, 90s. He's dead now, he's passed, but this was his technology. Let's just discuss switching. So in electronics, computers, everything is based on switching for the most part, whether it's a computer chip where they use binary code, 1 or zeros. Again, that's a type of a switch. Whether it's a light switch that we're mechanically flipping, on would be 1, off would be 0. And it's no different for this technology here. The whole heart of these motors is the switching technology behind it. So this particular motor, the Bedini motor, was built back in the day when these types of switches, which are called transistors, were economically viable. These particular ones are BJT trans. The difference between this device and our device here, the main difference is the switching tech. So this transistors that are used on this one here are not BJT transistors. They're MOSFETs or FETs. N-channel FETs. And all you need to know about this is basically these switches here. If you think of electricity as water, then the voltage is pressure, the flow or the amperage is flow. And if we stick with that analogy or metaphor, then basically these BJTs use flow as the switch. They require amperage to switch them on. And then these N-channel FETs, the MOSFETs, pressure sensitive switch, this is more of a flow sensitive switch. So flow, pressure, that's the difference in the switching that we're using for these two devices. And again, it's just a high level overview. If you get technical, the water analogy doesn't really hold true, but I think for beginners and just to keep everything clear, it's a good way of looking at it. Now, John Bedini, what do these machines do? So why is this different than just a regular motor? Well, it uses pulsing. So its waveform pulses electricity in this coil here from a battery, and it causes magnets on this rotor to be pushed away, because when we pulse into this coil, it causes a north pole to form, an electromagnet, and then these are the north-facing magnets on the rotor, so they repel one another. The key to this, though, is that when you put pressure or electricity into that coil, it causes a magnetic field. Now, when we shut off that electricity, the magnetic field collapses and causes a backflow of energy. So that backflow of energy we're capturing and putting into this battery here. So we've got a run and a charge battery. This flyback voltage, backflow of energy is key for what we are demonstrating here. So we're just going to stick with what's known to start, and then we'll get into the more fringe subjects based on this tech. But first off, what is this John Bedini motor? It's a battery charger. And again, it's a special type of battery charger because you're using a pulsed high voltage spike to charge that battery. A normal battery charger, such as the alternator in your car or just a regular battery charger, would use more of a constant voltage and high current. So a normal battery charger is going to use more flow and constant pressure. This battery charger here, a Bedini motor, if we look at it as a battery charger, it's using a high pressure and low flow way of charging the batteries. So why is that important? Well, it is better for battery charging to do a pulsed battery charge because it optimizes things like the sulfation. It's called a lead acid battery, these particular ones, and it's called that because there's acid and then there's lead plates, and the lead ions are what form when it gives it a charge. So that's what we're drawing the energy from in the battery, are these lead ions floating around in solution in the electrolyte, the acid. Now, lead sulfate forms on the plates in between charging as a process of it. This is not good because then it means there's less lead ions in the electrolyte in order for us to draw potential charge from. So a Bedini motor, those pulses actually break up the lead sulfate off the plates. So it keeps the battery fresher. It enhances the ion transportation efficiency because of this and the electrolyte kinetics within it. So it's very positive for the battery health, and that's fact. That's what pulsed DC electricity does to a battery. It's very good for it. So where am I saying that we can generate excess electricity from the pulsed DC effect, okay? Now, will this machine run forever the way it is? No, probably not. The batteries are going to run out. Does that mean that it's not producing excess energy? not necessarily so. You could still be producing more than you're putting in, but the batteries will eventually run out if you're doing work in the wheel, right? And there's losses within the coils. That's not the point. We don't think we're going to power our home with this machine over here. We do, but that's because it's set up much differently. But what is the working principle in us being able to do that? Well, when these high voltage pulses go into the battery, the lead ions versus the electrons. So these electrons that are in the high voltage spike being slammed into the plates are much lighter in their mass to charge ratio compared to the lead ions. So they're going to move much faster. And when they move faster past the lead ions, it creates a dipole, a negative and a positive, right? So that dipole within the battery is what is allowing excess energy to flow into the system. Now, how much different in weight to or mass to charge ratio are the lead ions compared to the electrons? Well, they're about 1,000,000 times greater in weight mass to charge ratio. Okay, so that's a huge amount. And that discrepancy in mass and charge is what allows this dipole to be created within the battery. This allows excess energy to flow. Where is it flowing from? Vacuum, zero-point energy, space, ether, quantum fields. It's coming in from somewhere else, from the environment. Again, we're not creating this energy for free. It's being allowed to flow in because of the dipole. And why don't we see more excess energy coming from this system here? Well, it's because this one is a 12-volt system. These switches, these BJT flow switches, amperage-based switching, is not as efficient as it could be. In order to get that dipole, you need very instantaneous switching because you want, the second this field collapses, you want to be able to capture it and slam it in there. So even if micro milliseconds is a big deal in this time frame. The time frames we're working with here are extremely like nanoseconds, very, very quick. So the voltage-based N-channel switches that we're using on this new build allow that. So the fact that this is only 12 volts, it's not as fast switching as possible, playing a part in why we're not getting a huge amount of excess energy off this machine. Our current build, we're stepping up to 120 volts. We've got multiple coils and we're using much faster switching. So that's the key. It's the amount of events, these dipole creating events, these spikes of energy that are going into the battery that are going to give you access to that energy flow that's coming in and putting excess energy into the system. Now, this energy flow that's coming into the system, is it electron-based? It's not. It can transform into electron-based flow and add energy to these ions and electrons, but it's coming in as some other form of energy. So some people call this a scalar component, a radiant component, and mainstream science does not support scalar waves. So Maxwell's and Lorentz current E&M theory, electrodynamics, that we get taught in school as electrical engineers does not support this. So this is contrary science here. And I just want to also mention that, it's not necessarily just as simple as measuring the in and the out, although I do have some nice DC amp and voltmeters here, clamp meters from Finsri that I've ordered. We will monitor what's coming into this as far as traditional electron flow that you can measure in and out, and I'm going to do a couple modifications in future videos just to tinker around, but this isn't constant DC electricity, right? So it's hard to measure. It's going up like this. Like you can't just use traditional measuring systems to measure the input and output of that. That's why on this build here, we're data logging everything, and to definitively prove that there is excess energy being produced, we're going to monitor how much work we've done. So we're going to generate electricity. You knew the total amount of potential energy within the system, all the batteries, and we're going to generate work, and at a certain point there's going to be enough work done that it's pretty definitive that there's still energy in the system. We've done this amount of work. Clearly this system has excess energy because it's an open system. It operates on an open system. Thermodynamic laws. You may have heard people talk about thermodynamic laws. Well, the thing about these laws that were written by men over the 1800s, 1900s, I think there's 5 of them: 0th, 1st, 2nd, 3rd, 4th laws. So these laws of thermodynamics are based on a system. What is a system? Well, it's a box that everything within, all of the energy inputs flows within it. So it's based on a closed system. Those thermodynamic laws are not necessarily being broken. They're just simply not valid because the system's bigger than what you originally thought based on your knowledge set of the environment. So that's how we're getting around thermodynamic laws. We're not. It's a bigger system. There's more energy in it than we originally thought. Now, one last little note I had here, the battery impedance is not constant. It depends on the frequency, the amperage, the temperatures, the charge, everything going on here. And again, that's why it's hard to measure this. We have to measure work done. We can't just stick clamps or amp meters on here and voltage and say, okay, this much wattage, this much in, this much wattage out, because you can't measure it accurately without like a true power meter. And for one, I'm telling you that the excess energy is coming into the battery. So if we're measuring the output from this battery and the input into this battery, and I'm telling you the magic happens in the batteries, well, then it's not accurate. So that's the whole point of this other build here, our new stepped up motor, is that we're going to be able to measure all of the inputs and outputs and the work done accurately and definitively prove that we can have excess energy in these types of machines, not because they're breaking laws, but because they operate on an open system. And there's just more to this world than we currently understand or recognize in our modern science. Now, so modern electrodynamics, physics, E&M theory, the kind of stuff that we're taught as electrical engineers in school, as physicists in school. It all started back with James Clerk Maxwell. So Maxwell wrote his famous equations. This guy was around back in the 1800s, like the 1860s, and he wrote Maxwell's equations. He was describing electromagnetic theory back in the day. During this time, there was no electron or atom. This was all developed like 40 years later, or that theory was developed 40 years later, discovered, if you will. So what did they believe back then? Well, back in the day, they believed in an ether. So they said that electromagnetic waves propagated through this medium, this ether, which is like a fluid that exists everywhere in space. So this ether allowed waves, electromagnetic waves, to propagate through. And that's just because, thinking about it, right, you can't have waves without some medium for them to propagate through. You know, think about waves in the ocean. They're using the water to propagate through. Sound waves are using the air as a fluid to propagate through. So this is how they were thinking about this back in the day when Maxwell wrote his famous Maxwell equations. I think there was like 20 of them at first. So Maxwell writes those, and then 30, 40, 50 years later, these two fellows come along, Oliver Heaviside and John Henry Poynting. So Heaviside and Poynting, they kind of refined Maxwell's laws. And they also were very famous because they talked about electromagnetic theory and the flow of energy through a system and these conducting wires. And they discovered that most of the energy that's flowing through a system is external to the conductor. So it's not in the wires at all. It's outside of the wires. There's a huge amount of energy flow outside of the wires, more so than the electrons flowing in the wires, which is pretty incredible when you think about it. Now, there was excess energy from Heaviside's equations that was outside the wires that wasn't accounted for, and it didn't quite line up with the mathematics at the time. So, like we often do, we need to make our observations match the mathematics that we're trying to put out, or we got to make the math match match what we're observing. Sorry. So, in order to do this, this guy, Hendrik Lorentz, who's a famous mathematician, this guy was amazing at calculus. Lorentz transformation is very profound and it's used in calculus. It's famous. But anyways, this guy comes along and he looks at Heaviside stuff and he's like, Heaviside, this equation doesn't really fit. There's still a bunch of excess energy flow outside of these conductors. I'm just going to differentiate it out. Bada bing, bada boom. The math works and we'll just negate Heaviside. So that's kind of where we're at with the history of where, from the ether. And then they're saying now here we're into like Einstein's time. Basically, Einstein comes along in the 1900s. He writes the theory of relativity, says that electromagnetic waves self-propagate. There's no longer an ether. They just self-propagate. We got rid of Heaviside's excess energy flow from outside the system. Calculus is wonderful. And then, we go through the 19th century and we kind of come back here where now we're in modern physics and they have quantum field theory and vacuum energy. There's quantum fluctuations in the vacuum. So now they're kind of recognizing, they're not calling it the ether, but actually in space, there's a huge amount of energy and quantum fluctuations and things that we can tap into. And, if you guys ask ChatGPT how much energy is available in vacuum or 0-point energy, everybody keeps saying, and it's true, 0-point energy is the lowest energy state. And that's true. It's a vacuum. There's nothing going on. It's void. There's no entropy is settled out. It's the lowest energy state. There's nothing there. But ask ChatGPT how much energy is available from that lowest energy state. 10 to the 113 joules per cubic meter. Literally infinite energy is available. And it'll tell you, we don't know how to tap it. But just the fact that it's admitting is it's there. So I think we basically went from like ether, vacuum energy, there's energy in space all around us, to no, there's not. It's theory of relativity, self-propagating, there's nothing. And then now we're back to where it's quantum and it's like, okay, so just keep this in mind, right? This stuff keeps changing. Science is continually changing. And our laws are not necessarily nature's laws. It's our best guess at how to describe nature. So don't let people tell you that things are impossible. They're not. We can do anything we set our minds to. There's always something new. Our laws are constantly changing. In fact, I don't think there's an example throughout human history where what was currently known and factual to be the absolute truth ever stayed valid through time. Like, it eventually changes, okay? So just because it's been 160 years or 200 years of thinking electromagnetic theory is this, doesn't mean that there's not more going on in behind this electromagnetism. Current E&M theory can be described and has been described. I think it was by Eric Dollard. So Eric Dollard and Tom Bearden are kind of theoretical guys. If you're interested in this stuff, definitely look into them, and I'll put the links in the channel. But they describe E&M theory as basically describing a whirlpool in a river and negating, just forgetting the river exists, but describing the whirlpool itself and saying that's, it's the whirlpool. It's like, yeah, but there's a whole river flowing to create the whirlpool. So is that what vacuum energy is? Possibly. Anyways, that's some theory. Got into it a little bit deep there. Now, let's talk about the build and what we've been up to, you guys, because it's looking absolutely incredible here. So Joe has completed these first electronics, and this is our N-channel MOSFET board switching circuit. We've got 8 individual circuits here. These are the power supplies. So basically, you're stepping down. This particular one's going to operate at 36 volts max. So 36 volts goes into the top here. It's stepped down by these DC to DC converters, buck converters, and then it powers a driver here, which drives the N-channel MOSFET here. Now, this N-channel MOSFET is silicon carbide. We're going to have the schematics from the system that we're currently going. It's not the final schematic, but just so you guys can follow along. For those of you who are hardcore and are going to try and build this themselves, we'll provide our current schematic, our bill of materials, the parts list, everything for you. And then once we get this working and the machine's working, we're going to put out the final schematics. Everybody gets them. Your BMO. I'll show you actually. I've got to insert, maybe I've already inserted the commercial, but JLC, this fabulous company that we were already working with, they do prototyping. They build all the PCB boards for us. They reached out and they said they would sponsor the channel. So we were ecstatic because they're amazing and we were already using them. So excited to have JLC as our sponsors on this video. JLC PCB, we'd already ordered our PCB boards from JLC, and then they reached out to us and they were like, hey, we like your channel, we love it, we'd love to sponsor you. Joe and I were both ecstatic because we already love their products. I want to show you the process in which we went from our line diagrams, our basic Bedini, everybody knows the classic Bedini circuit, our transistor. This is our upgraded version here using an N-channel MOSFET. Is completely different, right? We've gone from a basic line diagram, and then we go to the JLC PCB website, and basically what we need here is a Gerber file. Now, in order to get this Gerber file, we're using a program called Easy EDA. This is the board that Joe designed. So I'll show you the PCB board here. You can see we've got each of the individual 8 circuits. This is our MOSFET, our driver, the LED light, everything here. This is the board, how it's going to look. And then if you want to see the 3D view, this is the 3D view with all the componentry on it. Now, JLC can do full builds for you. They can put the components onto the boards in the future. We will probably utilize them to do that so that we don't have to hand solder everything. And by we, I mean Joe at the moment. Joe is doing it all. So once you've got your Easy EDA file here, you need to export it into a Gerber file. And then once you got your Gerber file, you can add it here to the JLC PCB website. It uploads it. It generates a model for you here. You've got a lot of different options, like the number of layers, the type of the board, the copper, the edging, everything. You go through it, you pick all your different options that you want. We went with the 2-layer, more basic board here for this particular one. So that's what we've got here. And then you can see it shows you what the board's going to look like, and that's exactly what our boards look like. They're also great because if there's a mistake like there was on our boards or any kind of errors, even after you've ordered, they will tell you and they'll allow you to fix it. So it's really good for that. Once you go through there and you get all your different options picked out, you order it, you can add the stencil. If you're hand soldering, you don't need the stencil, but depending on your level of knowledge, if you're somebody like Joe, then the stencils are applicable, and in the future I think Joe's going to get away from the hand soldering. There's also, like I say, the ability for them to, you can give them a BMO, bill of materials, and they will build the boards for you. They'll do everything. I'm super excited to work with JLC because they're not only just the PCB boards, but they've got prototyping labs, they got access to a machine shop, there's 3D printing, like literally everything. You guys got to check out their website, it's incredible. The final product, our boards came in here now. These particular boards we've now got populated. We've hand soldered, again, Joe's hand soldered all of the electronics onto these boards, but you can see they look phenomenal, just incredible. The quality is amazing. Everything's perfect. Thank you so much, JLC PCB, for sponsoring this. Incredible, you guys. Go to their website, upload your Gerber files, get your own PCB boards built. Joe and I will provide files for you, so if you guys want to do this for yourselves, you can take our files and upload them and get them printed off. Joe and I in the future will most likely give you the option to do it yourselves, buy the boards, buy the whole circuits, whatever. We can do all that with JLC. We're going to collaborate with them. It's going to be a good, long-lasting relationship, I can tell. So thank you so much, JLC. And on that note, I just want to go back into the boards here and show you exactly what we've done. So we've gone from this classic SSG Bedini motor diagram, and it's a simple schoolgirl, that's why it's what it's called. I mean, it's not complex circuitry. This is the BJT transistor in this one. This is the trigger coil. So then this one, that's what triggers the on and the off of the BJT transistor. Like we talked about, it's an amperage, a flow triggered switch. So this trigger coil switches it on, and energy flows like this across the battery through the coil, causes that rotor's motion. Then when the coil's switched off, the switch is closed and the back EMF flows into the battery, charging it. So that's it. On, magnets go, off, the back flow of energy charges the batteries. That's the gist of it. Now, this guy down here, we have, instead of a BJT, we have a N-channel MOSFET. And you can see down here, instead of a trigger coil, we have a MOSFET driver, which is driving the coil, and the signal we're getting is from an optic sensor in the timing wheel, right? So we're using these timing wheels to trigger these optic sensors here, and then that signal is being fed from this board into this driver down here, that guy right there with the capacitors across it. Just caps are just cleaning up the electric noise, and then we're going across into this N-channel MOSFET here. Same thing as this part here. This is the N-channel MOSFET's just replacing this BJT transistor. This is a better diagram of it. We've got the Hall, this one I wrote as a Hall effect trigger. You could use a Hall effect as well, but basically this triggering portion of it is this driver down here with the optic sensor driving this N-channel MOSFET, and then this main coil up here is now being connected to this section right here. You guys can see that pen there. So that coil goes in there, there's a fuse protecting it, and when this MOSFET is driven, it completes the circuit. And the same thing, this drives the coil on this bigger machine and or makes the rotor move. Now, when that field collapses, instead of going through a regular diode like these ones were here, we've got these silicon carbide diodes up right here. That's a silicon carbide diode. So that's a silicon carbide N-channel MOSFET, silicon carbide diode. Super high speed switching. That's the difference. That's the difference between that old BJT and regular diodes and all silicon carbide components. Very high speed switching. Incredibly excited to show you guys what Joe's beautiful electronics can do. Absolutely incredible, you guys. These electronics are state of the art. This machine is state of the art. I cannot wait to hook this up, and very soon that's what's going to happen. We're going to have these electronics with this optic timing put onto this device here. We're going to have the battery soon, and I can't wait to show you guys. So let me cut back to the video. Thank you so much, JLC. You guys are amazing. You guys check out JLC PCB website for all of your prototyping needs, whether they're electrical, mechanical, mechatronics, whatever you need. You guys are amazing. Back to our regularly scheduled video. Thank you guys. Now, what else have we been working on? Oh yeah, the crowdfund. Thank you so much. It literally warms my heart for just seeing the crowdfund and the amount of money that's coming, especially in the first couple of weeks. It's still up. If you can donate, please do. If you can't, just like, share, watch these videos. That's all that matters. We've got a few other things here. So we've got some different sized timing wheels with different widths of slot. So this will basically allow us to have different duty cycles for the optic sensor. In the future, we'll probably, but this optic sensor here, you can see it basically sits over top of this, and then these slots trigger this optic sensor, which then triggers these MOSFET gate drivers and allows this system to fire. So in the future, we're going to be able to retard and advance the trigger signal from these discs and optic sensor, but that's kind of down the road. We're going to have data logging on this. We're going to literally data log everything. It's looking incredible. I cannot wait to get this running. It's actually really close, you guys. We're going to fire up this first board using not the batteries, which we are buying, but we're going to do it with a DC power supply, just so then it's got some circuit protection and over amperage protection, just in case something goes wrong. We are going to enclose these boards. There is a danger of MOSFETs blowing up and things like that. So especially the very first try. So it is going to be a bit of a trial and error kind of thing. But overall, we're getting very close to firing this machine up. This big guy, it's going to be absolutely incredible. I cannot wait for this thing to be running. And one of these videos here, that's what it's going to be. It's going to be running when I turn on the camera for you. So next video, I think I got to fix up my shop a little bit. I'll probably do a video. I'll promise I'll get one out like every 7 to 10 days. I won't go as long as I did. I think this one's going to be 15 days by the time I get it out to you, but I'll try and do one every 10 days, 3 a month. The next one, we're probably going to finish off building the shop and buy the batteries. I'm going to have the battery trays built and just show you that we're choosing batteries that have the lowest internal resistance. They're car starter batteries, traditional electrolyte. They're not gel or AGM or anything like that. So we're going to go through some of the batteries in the future. And again, yeah, you guys, we're getting a website up and running. It's almost there. Reach out to me on the email, spencer@limitlesspotential.tech. I'll respond. Joe will respond. Joe, thank you so much, buddy. I love you. Kyle, thank you so much, you guys. It can't do it without you. We're working together. We're collaborating. That's what this is. This is a new way of doing things. Open sourced from the bottom up, not from the top down, centralized, open collaboration. So if you guys want to reach out, you got skills, you can help me in any way, that'd be amazing. I could still use a little bit of video editing, whatever you can afford. If you can contribute to the GoFundMe, links in the video. I absolutely could not do it without you guys. This is going to be incredible. We're able to go so much faster with these donations. Joe and myself are donating all of our time. Joe's working like an extra 20, 30 hours a week building these electronics. You should see the next phase 2 electronics he has. Like, these ones are absolutely incredible. Just wait till you see the next ones, like world-changing electronics. And you guys get access to this too. We're not hiding this. We're giving you guys all of these little secrets. Everything's open source. Remember that. That's the purpose of this project. Nobody's getting bought out. Nobody's going into hiding. Nobody's in fear. We're here for you. We're all working together. Everything's great. We have faith. We know the end goal that we're going to. The path is showing itself. We have faith and we're protected because of that. And I guess that's where I'm going to leave it at this one, you guys. I love you all. I'll make a new video much quicker than the last one. I'll get one out here in the next 7 to 10 days. We'll go over the Bedini. We'll do a few measurements. We'll show the batteries. Big thanks to JLC. Thank you so much. We love you guys. We're already using your stuff. You guys check out the website. I'll put the links in the videos. And thank you to, they've sent us some different electronics, very affordable meters, devices, power supplies, fabulous companies from China. I love you guys. I love you all. Remember, limitless potential in all of us, all things. We can change the world, and we are changing the world. Nothing's going to stop us. So stay tuned, you guys. You're coming along for the ride, and it's going to get exciting here. This thing's going to be up and running very soon. Next couple months, 2025, free energy is released to the people.